In this lab, you create a PCB editor design.brd file. This design file will contain only mechanical data. No logical schematic data will be loaded. This design file serves as a master template or starting point for all layouts that require its mechanical specifications. This ensures that all physical layouts with common geometry start from a mechanical template that has been thoroughly checked and approved for use. Start by opening the Allegro editor and say File, New. And we've already saved this drawing, so we say No. And the drawing name, let's call it Master. And the drawing type will be Board. And we can say OK. And we want to click the Setup and Design Parameters. And we want to open up the Design tab. And the size drawing that we want is C size. User units is mils. Accuracy, let's make it 2. So we've put the left x at -3000 and lower y at -3500. That'll bring the corner of the board to the left 3 inches and the lower corner down 3,500 mils, which is 3.5 inches. So we can see our 0, 0 point is right here. And as you recall, we did a -3000 in the x and a -3500 in the y, which brings that corner right there. And the next thing we do is going to place manually an outline. And so we go Place and Manually. And we want to click on the Advanced Settings tab. And we also want Database and Library. And then we go to the Placement List. And we want Mechanical Symbols and Outline. And once you have your symbol, just type in X space 0 space 0. And the symbol that we created flies right into the 0, 0 point. The next thing we're going to do is create a symbol path report. It's very important to know where your symbols are coming from as far as which library they're coming from. Your company would probably have several different libraries for different applications, and we want to make sure that the path for the library is correct. First we go to Tools, and then we go to Reports, and then we scroll down to Symbol Library Path Report. Now, you have to double click it because it's not going to make the report unless it goes into this area here. So we double click, it's there, and we say Generate the report. And we look and we see that it's coming from the Allegro 17.4 All Basic Play, which is where we created our board outline. So we are good to go. And if you want to know where the symbol path is stored, we go to Setup, User Preferences. We see that there's something called Paths. And then we go to Library, and we see that the PSM path is what we wanted to know. This PSM is the symbol path. So we click on this little button, and we see that the path is there, and if it didn't find it here, it would go to an alternate PSM path, which is comes with the Allegro software. And if you want to make another one, you just click this, and then you have this little button here that you press, and then you can go and you look for whatever folder you want, and then you just say OK, and off it goes. And the next thing we're going to do is add format symbols to our drawing. And the way we do that is we go into Place and Manually, and let's take a look at our advanced settings. We do want it to go to a library, and we will click Auto Hide, and let's go to the placement list, and we want format symbols, and we are in the format symbol folder, but I just wanted to show you that there are many choices, and we do want format symbols, and we want a B-size drawing because it is right now we're in a C-size format, and let's put it right about there, and our format is added. And another thing we're going to add to this drawing is assembly notes. So we click on that. Our notes come in. We put it maybe here. And this is usually a standard, a set of standard notes that your company might want. You might have several different general notes that you might want depending on what kind of a technology you're using to fabricate the board. Another thing we want to add is a connector which goes into this area right here, and that connector is called a DIN64. And if we go over to here, we put we click on package symbols, and you got lots and lots and lots of package symbols. We can put DIN64 because we know what it is, and 64, and there it is. We'll just click on that, and there it is. And our engineer tells us to place it at X minus 700, 500. And we put that in there, and we just hit and enter. And if we zoom in a little bit, like right to there, we can see that that connector has been placed. And if you remember, we did put a via keep out area in this area right here, and it looks like everything is correct. The engineer wants to add a couple of BNC connectors to the drawing, and he wants it placed at this point, and then we'll rename it later. So the way we do that is we go into Place, Manually, and let's open up the Advanced Settings tab. We want to make sure that the library is checked, and it is. And we want to go to the placement list, and we want to put in BNC. And we see that there is a BNC. We'll click on that, and that's it right there. And the engineer has given us a specific placement of 3700 in the X and 300 in the Y. So we type that into the command line and hit enter. And it looks like it's placed properly. And we want to add one more. And the engineer has given us a placement of X 3700 and the Y is 1100, and we just hit and enter. And that takes care of the two BNC connectors. And we can right click and say done, and that gets us out of that routine. The next thing we're going to do is control visibility and color. We created a parameter file that sets color and visibility for various layers of the drawing. You use that parameter file now. We choose File, Import, and Parameters. And we're going to choose a parameter file that we created in an earlier lesson called Colors. And you can either type it in, or if you use this button, you'll see that it's right there. And we can open it and import it. And you can see that the only thing that we have is what's important to us. All our other data is gone. All the dimensioning, formatting, and fab notes are gone. And we can close this user interface. And the next thing we're going to do is define the cross-section layer stackup. By default, all new design files are created with just 2 layers, top and bottom. In this part of the lab, you're going to learn how to add more layers to the stackup. We go to Setup and Cross-Section. And this user interface pops up. And we're going to reset this to the Cadence defaults. So we go to View, Reset User Interface to Cadence default. This is done only for the purposes of this video so that you can match the steps. And the next thing we're going to do is right-click in a blank layer, and we're going to put Add Layers. And the count of the new layers is going to be 2, and it's going to be a plane, and it will be copper. And add. And we're going to click layer 2, and we're going to call it ground. And layer 1 will be VCC. And now we right-click on the ground layer, and we say Add Layers. And this user interface pops up. And we have 2 layers here, and we want it below the ground. And it's going to be a conductor layer, and it's going to be copper. And we're going to say Add. And we can rename this to INT1 and INT2. We will double-click the Types button here. I'm going to add another constraint here, INT con. And we add INT underscore COND. And we're going to do the same thing here. Done. And the next thing we want to do is double-click Physical. And on the VCC layer, we're going to allow it to be a negative artwork. And next we go to Display Status. And we're going to look for this dynamic fill, and right now we want this disabled, which is correct, and we say OK. Our schematic capture tool is going to be CIS, so we want to save this board to the Project 2 directory, and to do that we say File, Save As, and then we go to All Basic Play, which is right here. And then we keep going. And we want Project 2 and save it. And we can exit out of this. And that concludes this part of the lab.